Deep in the cosmic void, a signal repeats. It cuts through the static of a swirling stellar nursery, a place where stars and planets are born. These are interstellar molecular clouds, vast and dark, and they are broadcasting secrets. From their depths, astronomers have catalogued 25 bizarre, unexplained transmissions. These are not random whispers of the universe. They are structured, powerful, and they defy everything we think we know about physics. By the end of this journey, you will understand the genuine cosmic mysteries that could force us to rewrite the rules of reality or reconsider our place in it. We will explore signals that flicker with impossible precision, pulses that vanish without a trace, and one chilling spike on a frequency reserved for listening. What does it mean when the universe itself seems to be sending a message we cannot yet decode? The first clue emerged from a seemingly ordinary patch of cosmic darkness. Catalogued simply as Signal 1, it came to be known as the Wow Cloud Anomaly. It was not a burst or a chaotic crackle. It was a single, piercing note, a narrow-band radio emission so focused it seemed to cut through the background noise like a laser. This signal was detected right at the boundary of a vast molecular cloud, a place of turbulent gas and nascent stars. What made it so strange was its frequency stability. In the natural cosmos, radio waves from objects like pulsars or the emissions from cosmic masers tend to drift, smear, or show telltale signs of their violent origins. This signal did not waver. Its frequency was locked in place with a precision that, in our own technological world, we associate with carefully engineered transmitters. Visualize a spectral graph, a line showing the intensity of radio waves across different frequencies. The background would be a messy, rolling landscape of natural static. And then, right in the middle, a single, impossibly sharp spike shooting straight up. It was a non-thermal emission, meaning it didn't come from simple heat. It was structured. The natural explanations began to fall apart. A pulsar's signal spins and pulses with a rapid, predictable rhythm. This was a steady tone. A cosmic maser, which is like a natural laser for microwaves, often produces emission that is broader and comes from specific molecules in chaotic environments. This signal was too narrow, too clean, too precise for that. So we are left with a profound question hanging in the silent data. What natural process within a chaotic stellar nursery could possibly generate a radio beacon of such stunning, unwavering focus? The structure of that spike suggests physics operating with a level of coordination that borders on the intentional. That single, perfect spike was a mystery of stillness. But the next signal from the cosmic archives is one of chaotic, frantic motion. Signal 2, the eerie hydrogen flicker, is a ghost in the machine of the universe's most common element. Astronomers listen intently to the 21-centimeter line, the quiet hum emitted by neutral hydrogen atoms as their electrons flip their spin. It is a fundamental heartbeat of the cosmos, a steady background whisper used to map the structure of galaxies. But within one particularly cold, dark molecular cloud, that heartbeat began to stutter. The signal did not just vary, it flickered with rapid, seemingly random intensity changes, spikes and dips that far exceeded anything thermal physics could explain. This cloud was not being warmed by newborn stars. It was a deep freeze, making standard excitation mechanisms like collisions with other particles incredibly unlikely. The quiet hum had become a frantic, chattering static. So what could possibly be agitating these hydrogen atoms in such a profound and erratic way? One leading theory points to the invisible scaffolding of the universe, dark matter. We know dark matter clumps together in vast halos around galaxies, but it may also form smaller, denser substructures like cosmic filaments or tiny, dense knots. If one of these unseen dark matter clumps were drifting through this cold molecular cloud, Its immense gravitational influence, or perhaps even a rare interaction between dark matter particles and the hydrogen itself, could be injecting bursts of energy. It would be like an invisible stone dropped into a still pond, sending ripples through the fabric of space that jostle the atoms, making them flicker in a way we can detect. Another possibility is even more transient. Imagine a high-energy cosmic ray, a proton traveling at nearly the speed of light from a distant supernova, slamming directly into the heart of this cloud. That single catastrophic impact could create a microflare, a tiny, localized explosion of energy that briefly and violently excites a pocket of hydrogen, creating a burst on the 21-centimeter line that looks, for all intents and purposes, like an intelligent signal. Distinguishing between these possibilities, a passing ghost of dark matter or a single cosmic bullet, demands incredibly complex spectroscopic analysis, peeling apart the light to look for chemical fingerprints or patterns in the flickering. But the result is the same. A fundamental piece of our cosmic map, the hydrogen line, has been hijacked by something we cannot see, broadcasting a message of chaos from the cold. The frantic flicker of hydrogen was a signal of invisible turmoil, but the third signal on our list presents a mystery of impossible unity. Astronomers call it the molecular cloud monopole emission. Picture a vast, dark nebula, light years across, a turbulent sea of gas and dust where magnetic fields twist and churn. Within such a chaotic environment, you would expect any radio emission to be patchy, flickering, coming from localized knots of activity. This signal defies that completely. It is a low-frequency hum, a deep, resonant tone that appears to emanate uniformly from the entire cloud structure. The entire cloud seems to be acting as a single, giant, non-directional emitter, glowing with a coherence that should be utterly impossible for its size and nature. It is as if every molecule in that sprawling cosmic fog were singing the same note in perfect unison. This presents a profound theoretical challenge. For a natural object to produce coherent radio waves like this, the charged particles within its plasma need to be aligned, their motions synchronized by a powerful and organized magnetic field. Think of it like a cosmic choir where every singer must follow the same conductor's baton. In the violent, turbulent interior of a molecular cloud, magnetic fields are tangled and chaotic, not the uniform sheets required to conduct such a perfect symphony. The forces that stir these stellar nurseries, from internal turbulence to the shockwaves of nearby supernova, should rip any large-scale coherence apart. So what force could possibly orchestrate this? One fringe hypothesis suggests the cloud might be threaded by a previously undetected type of cosmic string, a theoretical defect in the fabric of space-time left over from the Big Bang, whose immense gravitational influence could align matter across vast distances. Another, even more speculative idea wonders if we are seeing the signature of a technology so advanced it uses the cloud itself as a resonant cavity, a natural amplifier for a signal meant to be heard in all directions. Whether the answer lies in exotic physics or something else, the monopole emission stands as a stark reminder that our models of these cosmic clouds are incomplete. We are looking at a choir singing as one, but we cannot find the conductor. That impossible unity gives way to a signal of deliberate, rhythmic change. From another cloud, we have the repeating water maser shift. A cosmic maser, as we mentioned, is like a natural laser where molecules like water are excited to amplify specific microwave frequencies. They are common in star-forming regions, and they typically exhibit some predictable drift in their frequency as the gas they inhabit moves. But this particular water maser signal does something profoundly odd. It does not drift smoothly. At regular intervals, its entire emission band abruptly jumps to a different frequency, like a radio station suddenly and cleanly switching to another channel, only to switch back again later. This periodic shift defies the standard rules of motion within these clouds. It is non-Keplerian, meaning the shift does not follow the smooth, predictable curve of an object in orbital motion, like a planet around a star. The abruptness also rules out general internal turbulence, the churning chaos of the cloud itself, which would cause a messy, smeared shift, not a clean, discrete jump. So we must ask, what force could reach into a cloud and selectively retune this natural amplifier on a schedule? The most compelling and controversial hypothesis points to an invisible titan passing through. Imagine a massive, dark object like a rogue planet many times the size of Jupiter, or even a stellar mass black hole, on a high-speed trajectory that takes it through the outskirts of this molecular cloud. As it passes, its immense gravitational field would warp the local spacetime, effectively stretching and compressing the region where the maser emission originates. According to Einstein's theory of general relativity, this warping would cause a gravitational redshift or blueshift, abruptly changing the frequency of the light we receive from that specific patch of excited gas. The object itself would be completely dark, emitting no light of its own, but its ghostly gravitational influence would be written into the sudden leap of the maser's signal. The periodic nature of the shift suggests this dark traveler might be on a long, elliptical path, periodically swinging close enough to the maser region to tug on it before receding again. We are left with the haunting possibility that we are not seeing the signal of the cloud itself, but the shadow of something far more massive and mysterious moving silently through it, a phantom signature written in shifted light. The phantom's gravitational tug warps light, but our next signal offers a rhythm of its own, one etched in time with atomic precision. Deep within the dense, sooty heart of a carbon-rich molecular cloud, astronomers detected a series of short, sharp bursts. Each burst was a packet of highly structured radio energy, a complex fingerprint that suggested more than random noise. The real shock was the timing. These bursts repeated precisely every 4.3 hours, not 4.29, not 4.31, 4.3 on the dot, like a cosmic metronome set billions of years ago. This is the carbon ring echo. Such exact periodicity presents a monumental puzzle. In astrophysics, natural oscillators exist, but they are rarely this clean. A pulsar, a spinning neutron star, can have incredible precision, but its period is measured in milliseconds or seconds, not hours. The rotation of a large, solid body, like a planet or an asteroid, could produce a multi-hour period, but within the chaotic, gaseous environment of a molecular cloud core, any solid object of sufficient size would be glaringly obvious through other means, and its rotation would be subject to drag and perturbation, causing tiny, detectable changes in its period over time. The carbon ring echo shows no such drift. Its clock is perfect, so what inside a cloud of gas and dust could possibly keep time so well? One fascinating line of inquiry points to the very chemistry of the cloud itself. These regions are rich in complex carbonaceous molecules, the building blocks of life. Some theorists propose that we might be witnessing the vibrational modes of truly gigantic molecules, perhaps Fullerene cages or carbon nanotubes on a macroscopic scale, structures large enough to resonate at radio frequencies as they flex and breathe. If such a megamolecule were spinning or vibrating in the near-perfect vacuum of interstellar space with minimal external interference, it could, in theory, act as a remarkably stable natural resonator, ringing like a bell on a strict schedule. Yet the structured nature of the bursts themselves, not just a simple pulse but a complex signal, pushes against a purely chemical explanation. This leads to the more sensational and profoundly unsettling possibility. What if the periodicity is not a natural resonance but a carrier wave? The 4.3-hour cycle could be an engineered frame, a blank slate upon which information is encoded within the intricate structure of each burst. The choice of a carbon-rich environment is particularly suggestive. Carbon is the backbone of organic chemistry, the element of life as we know it. Could this be a beacon deliberately utilizing the natural molecular transitions of carbon compounds as a recognizable signpost, a way of saying, look here where the ingredients for life are abundant? The chilling elegance of the carbon ring echo lies in this duality. It is a signal that sits perfectly on the razor's edge between a newly discovered natural phenomenon and a message waiting in the dark, ticking away with impossible patience. The precise rhythm of the carbon ring echo gives way to a chemical mystery written in molecular light. Signals 6 and 7 arrive as a pair, a cosmic duo detected emanating from the same dense, tiny knot within a sprawling cloud. They are the methanol and formaldehyde twins. On their own, each molecule is a familiar character in the interstellar story. Methanol, a simple alcohol, and formaldehyde, a basic organic compound, are common building blocks found throughout star-forming regions. What makes this pair an anomaly is not their presence but their performance. The methanol emission line is blazingly, unexpectedly strong, while the formaldehyde signal from the exact same location is curiously faint. This imbalance breaks a fundamental rule of cosmic chemistry known as thermodynamic equilibrium. In a stable, undisturbed pocket of gas, molecules reach a natural balance with their environment, their emissions settling into predictable ratios based on temperature and density. Here, that balance is shattered. It is as if a spotlight were shining directly on the methanol molecules, exciting them to shout, while leaving the formaldehyde molecules whispering in the shadows. Something is providing a burst of energy, but it is not heating the entire region evenly. This energy is selective, preferential, almost as if it is tuned to a specific molecular frequency. So what external force could play such favorites with interstellar chemistry? The leading hypothesis points toward a rain of exotic particles. Cosmic rays, high-energy protons and atomic nuclei constantly bombard these clouds and can drive chemical reactions. But standard cosmic rays tend to create a more chaotic, broad-based excitation. To explain this specific, targeted boost to methanol, scientists are considering the possibility of something more unusual. Could low-energy cosmic rays with just the right amount of energy be striking this pocket of gas? These would be particles not traveling at near light speed, but moving slower, carrying energy that matches the exact vibrational or rotational states of the methanol molecule. When such a particle collides with methanol, it could deposit its energy with perfect efficiency, making the molecule glow brightly at its specific radio frequency, while leaving neighboring formaldehyde relatively untouched. An even more speculative idea involves the indirect effects of dark matter. If certain theoretical dark matter particles were to collide and annihilate within the cloud, they would not produce light directly. Instead, they could release a spray of secondary particles like electrons or positrons with very specific energy ranges. This tailored particle shower could, in theory, selectively energize one type of molecule over another, creating the strange emission ratio we observe. The methanol and formaldehyde twins are therefore more than just two signals. They are a forensic clue. They tell us that within this dark nebula, an invisible process is at work, one that interacts with the very architecture of molecules in a precise and discriminating way. We are not just listening to the cloud, we are reading its disturbed chemical ledger, and the entries point to a particle physicist's puzzle hidden in the stars. This selective chemical excitation is a quiet, localized mystery, but the eighth signal shatters that calm with a burst of frantic energy. It is called the chirping helium pulse. Within a cloud unusually rich in helium, astronomers captured a radio event that lasted mere milliseconds. Yet in that fleeting instant, the signal did something extraordinary. It swept rapidly upward across a fixed band of frequencies, producing a distinct chirp like the sound a radar makes but born from the depths of interstellar space. The speed of this frequency sweep is the key to its strangeness. In a natural cosmic setting, a shift in frequency usually points to motion, the Doppler effect. If a cloud of gas is collapsing or a star is moving toward us, the light it emits gets compressed, shifting to a higher frequency, a blue shift. But the rate of change in this chirp is impossibly fast. To produce such a rapid sweep through Doppler shifting alone, the source would need to be accelerating at a rate that would tear any known celestial object apart. It is not the gentle drift of a drifting gas cloud, it is the scream of something undergoing a catastrophic, instantaneous change. So what inside a helium-rich cloud could possibly chirp? One fringe theory points to the bizarre behavior of matter under extreme conditions. Helium, especially in its isotope helium-3, can become a superfluid at temperatures near absolute zero, a state where it flows without friction. Some speculative models suggest that if a dense nugget of ultra-dense matter, like a strange quark star fragment or a microscopic black hole, were to pass through a superfluid helium region, the interaction could create a shockwave that releases a chirping burst of radio waves as it moves. The frequency sweep would then map the changing conditions along its path. A more grounded, yet still mysterious, possibility connects this signal to one of astronomy's greatest modern puzzles, fast radio bursts. These are immensely powerful, millisecond flashes of radio waves from deep space, often originating far outside our galaxy. But what if some fast radio bursts are not extragalactic? What if this chirp is a local fast radio burst generated deep within the molecular cloud itself? The dense, magnetized environment of the cloud could provide the perfect engine, perhaps through the sudden reconnection of magnetic field lines around a newborn star or the collapse of a particularly dense core, launching a blast of energy that chirps as it propagates through the cloud's outer layers. The helium-rich environment is a crucial clue, as it suggests a region where nuclear processes involving helium might be involved in powering the event. Whether it is the death cry of an exotic particle or a magnetic lightning strike within the cloud's heart, the chirping helium pulse reminds us that the most profound cosmic messages can be the briefest, leaving us with just a millisecond of data and a lasting echo of questions. The chirp of helium fades into a whisper, leaving behind a different kind of thermal impossibility. Signal 9 is known as the silicate signature discrepancy, and it reads like a cosmic crime scene where the evidence contradicts the environment. Astronomers detected the clear, sharp emission lines of silicate dust grains, the same kind of fine, glass-like particles found in interstellar clouds and around newborn stars. These grains were excited, vibrating and emitting infrared light at specific frequencies. The problem was the location. This signal came from a cold, dark core of a molecular cloud, a region so frigid and shielded from starlight that its temperature hovered just a few degrees above absolute zero. At such a deep freeze, the silicate dust should be inert, sleeping quietly. It should not be glowing with that specific signature. It is as if you walked into a walk-in freezer and found a single red-hot iron bar sitting on a shelf, radiating heat in a room built for ice. The energy required to excite those dust grains to that level simply does not exist in that part of the cloud. No nearby star is shining on it, no shock wave from a recent cataclysm is warming it. So we are forced to ask what invisible hand is holding that iron bar, pumping energy directly into the dust. The leading suspect is a form of radiation we are currently blind to. Imagine a powerful, localized burst of non-ionizing radiation. Unlike X-rays or ultraviolet light that strip electrons from atoms, this would be a subtler form of energy, perhaps in the far infrared or submillimeter range, perfectly tuned to make silicate molecules vibrate without tearing them apart. This burst could be so brief and focused that our telescopes, which often take long exposures to gather faint light, would completely miss the source itself. We would only see the aftermath, the warm dust grains left glowing in the dark long after the invisible flash has passed. What could generate such a precise, hidden energy spike? One possibility is a magnetic reconnection event deep within the cloud's heart, a sudden snapping and realigning of magnetic field lines that converts immense magnetic energy into heat and radiation in a very confined volume. Another, more exotic idea involves the decay or interaction of exotic particles like actions, a theoretical candidate for dark matter. If such particles were to decay or collide within that specific core, they could release energy in just the right wavelength to tickle the silicates and nothing else. The silicate signature discrepancy is a ghostly footprint. We are not seeing the creature that made it, we are only seeing where it stepped, leaving behind a patch of inexplicably warm dust in the cosmic deep freeze, a clue that something potent and unseen is moving through the shadows. That inexplicably warm dust is a footprint of hidden energy, but our 10th signal presents the opposite problem, a profound and unsettling absence. Astronomers call it the nebulous noise filter. Within a specific interstellar molecular cloud, researchers pointed their radio telescopes expecting to hear the standard cosmic static, the predictable hiss of synchrotron radiation from energetic electrons spiraling in magnetic fields, blended with the faint thermal murmur of warm gas. Instead, they found a perfect silence. Across a narrow but distinct band of frequencies, all the expected background radio noise simply vanished. It was not a weak signal, it was a complete void, as if someone had placed a cosmic shield in front of the cloud, blocking only that specific slice of the radio spectrum. This created a clean, artificial-looking dip in the data, a filter applied to the universe's natural soundtrack. The implications are staggering. What inside a cloud of gas and dust could possibly act with such selective precision? One theoretical avenue points to a highly specialized plasma effect. If conditions within a vast region of the cloud were just right, with a specific density and magnetic field alignment, the plasma could, in theory, absorb radio waves at that exact frequency through a process called cyclotron absorption. But for this to work over such a large area, the plasma would need to be unnervingly uniform, a perfect cosmic laboratory condition that nature almost never produces on such a scale. The more profound explanation involves the cloud's very architecture. Imagine an immense cold structure made of a particular molecule we have not yet identified, a complex compound forged in the cloud's depths. This megamolecule would have a specific rotational transition, meaning it naturally absorbs and re-emits energy at one precise radio frequency. If this molecular structure were vast enough, spanning light years, and cold enough to be in its lowest energy state, it would act like a colossal sponge, soaking up all the background noise passing through the cloud at that frequency. We would see a perfect absorption line, a slice of silence etched into the data. The problem is, for this to work, the structure must be coherent and immense, a single chemical entity operating on a scale that challenges our understanding of how molecules form and persist in space. It would be less like a cloud and more like a cosmic-scale crystal, a frozen lattice selectively filtering the light of the galaxy. This signal does not ask us what is emitting energy, but what colossal, ordered structure is standing in the way, casting a radio shadow so perfect it looks engineered. The nebulous noise filter is not a message written in light, but in darkness, a silence that speaks volumes about the hidden architecture of the cosmos. That perfect radio silence is a shadow cast by something vast and still, but our 11th signal requires a precise cosmic alignment to even be seen. The galactic center alignment signal emerges only under one specific condition, when the interstellar molecular cloud in question sits in a direct, perfect line between our telescopes and the supermassive black hole at the heart of our own galaxy, Sagittarius, a star. During these rare windows, the cloud begins to broadcast a faint but complex radio signature that vanishes the moment the alignment is broken. At first glance, this seems to point to a natural lensing effect. Just as a glass lens can bend and focus light, the dense material of the cloud could, in theory, gravitationally lens and amplify background radio waves from the chaotic region around the galactic center, making a faint signal temporarily audible. But the details unravel this simple explanation. The signal's spectral characteristics, the specific way its energy is distributed across different frequencies, do not match what we would expect from lensed background noise. Lensing from a diffuse cloud would smear and distort the signal, creating a messy, broad-spectrum glow. What we detect is structured with sharp peaks and a curious symmetry that suggests coherence. It is less like hearing amplified chaos and more like hearing a clear tune played through a megaphone. This forces a difficult choice between two extraordinary possibilities. The first is that the cloud itself contains a directional emitter, a natural or artificial structure that only activates or becomes visible when it is backlit, in a sense, by the immense energy of the galactic center. Perhaps some exotic material within the cloud resonates or becomes excited only when bathed in the specific blend of radiation streaming from that direction. The second, even more mind-bending possibility is that the signal originates from far beyond the cloud, from an object located directly behind the galactic center itself. In this scenario, the cloud is not the source but a necessary filter. Its complex chemistry and magnetic fields might be subtly altering a distant signal, cleaning it up or imprinting a specific signature, and only when the alignment is perfect can that filtered signal travel to us without interference. Either way, the galactic center alignment signal behaves less like a natural phenomenon and more like a cosmic keyhole, a portal that opens only when the universe lines up in a very specific way, offering a fleeting glimpse of something that either hides within the cloud or lies in the darkness far beyond the heart of our galaxy. That cosmic keyhole only opens under perfect alignment, but the 12th signal demands no such precision. It erupts on its own chaotic schedule. Known as the iron isotope flare, this signal is a fingerprint of a specific, heavy form of iron, iron-60. This isotope is radioactive and rare, forged only in the violent final moments of a supernova. Its presence in a molecular cloud is a clue in itself, a ghostly remnant of a stellar explosion that seeded this nursery with heavy elements. But the behavior of this iron-60 is the true mystery. Instead of decaying with a steady, predictable quietness, it flares. Astronomers detect intense, unpredictable bursts of gamma rays linked directly to its decay, as if something is violently shaking the nucleus, forcing it to release its energy in sudden, dramatic pulses rather than a slow trickle. In the cold, dark quiet of a molecular cloud core, this is utterly bizarre. There is no ambient heat or radiation powerful enough to agitate an atomic nucleus in this way. It should be sleeping. Something is repeatedly hitting the snooze button with a sledgehammer. So what force can reach into the heart of an atom and provoke it so violently? The leading suspicion falls on the densest, most extreme objects in the universe. A newborn neutron star, the collapsed core of a dead star, could be hidden deep within the cloud. As it spins, a neutron star's unimaginably powerful magnetic field, trillions of times stronger than Earth's, can create immense electrical storms in the surrounding space. If this field were to interact with a pocket of iron-60 dust, it could theoretically induce nuclear reactions, effectively exciting the isotopes and triggering those gamma-ray flares. An even more exotic possibility is the presence of a quark nugget, a hypothetical lump of ultra-dense matter made of raw quark material. Such an object drifting through the cloud could act like a cosmic catalyst. As normal matter, like the iron isotopes, accretes onto its surface, the immense pressure could trigger unusual nuclear processes, causing the iron to flare as it is crushed and transformed. The iron isotope flare is a signal of deep elemental violence. We are not just looking at the aftermath of a long-dead star, but at its restless remains, perhaps still churning in the dark, using the very atoms it created as a volatile fuel to send out sporadic, brilliant flashes. It is a reminder that within these serene clouds of gas, the engines of stellar death may still be ticking, their influence written in the unstable heart of a single, heavy element. The restless glow of radioactive iron gives way to a signal of chilling mathematical perfection. Deep within an isolated cold core, where temperatures plunge near absolute zero, astronomers detected the unmistakable signature of the ammonia molecule. This in itself was ordinary, but the data revealed something extraordinary. Alongside the fundamental frequency, the main note of the ammonia emission, stood a series of additional, perfectly spaced peaks. These were high-order harmonics, precise multiples of the base frequency, ringing out with a clarity that defied the frozen silence. In our world, think of a guitar string. When you pluck it, you hear the fundamental tone, but also quieter, higher-pitched overtones, the harmonics that give the note its richness. In the natural cosmos, ammonia masers act like that plucked string, almost always producing only that strong, fundamental tone. The chaotic environment of a molecular cloud damps out any higher-order vibrations almost instantly. To generate these distinct, clean harmonics requires something radically different. It demands a highly non-linear energy transfer mechanism. This is a technical way of saying the energy pumping into the ammonia isn't just warming it up evenly. It's hitting it in sharp, precise kicks with a force and timing that forces the molecules to vibrate in multiple, synchronized patterns at once. It's the difference between gently warming a bell with your hands and striking it perfectly with a hammer. One produces a dull warmth, the other a clear, ringing chord with all its overtones intact. So what inside a dark, frozen cloud could possibly wield that hammer? Natural maser action, driven by gentle radiation or collisions, simply cannot achieve this. The precision points toward a structure, a cavity or resonator within the cloud itself, that is somehow shaping the energy. Some researchers quietly speculate about engineered resonators, natural or otherwise. Could a vast geometric formation of dust and ice, a crystalline structure on a planetary scale, be trapping specific frequencies of light and then re-emitting them in this perfectly harmonic series? The signal behaves as if the cold core itself has become a cosmic musical instrument, and something or someone is playing a chord so complex it reveals a craftsmanship hidden in the chaos. That harmonic chord of ammonia suggests a hidden cosmic craftsmanship, but the next signal points to a chemistry so advanced it seems borrowed from a laboratory. Signal 14 is the polysiloxane ghost emission. On Earth, polysiloxane is a synthetic polymer, the backbone of silicones found in everything from sealants to medical implants. It is a chain of silicon and oxygen atoms with organic side groups, a complex manufactured molecule. Yet, astronomers detected its unmistakable spectral fingerprint, a specific pattern of infrared absorption lines emanating from the extreme outer boundary of a molecular cloud, a region exposed to the harsh radiation and particle flux of interstellar space. The immediate, instinctive reaction is to dismiss it as contamination, a stray signal from a satellite or some earthly source. But the distance is astronomical, and the signature is locked to the cloud's own motion against the background stars. This molecule is undeniably out there in the void. Its presence there is a monumental chemical puzzle. In the sparse, cold environment of a cloud's outer rim, the formation of such a complex silicon-based structure should be nearly impossible. Simple silicon oxides like silicon monoxide are common, but building long chains of alternating silicon and oxygen atoms and then attaching carbon-based side groups requires a very specific and energetic pathway. Standard models of interstellar chemistry, which work well for carbon-based organic molecules, struggle to explain how silicon, which tends to bond with oxygen to form solid dust grains like silicates, could be pried loose and woven into such an elaborate organic-like polymer in the gas phase. So how did it get there? One radical line of thought looks to the environment itself. That outer boundary is a violent place bombarded by ultraviolet starlight and cosmic rays. This relentless energy could be shredding pre-existing silicate dust grains, blasting silicon atoms into the gas where they might, under just the right conditions, link up with oxygen and carbon monoxide molecules in a stepwise process catalyzed by the very radiation that seems destructive. It would be a form of extreme chemistry, forging complex molecules in a cosmic crucible. The other, more profound implication whispers of a different possibility entirely. On Earth, carbon is the element of life because of its versatile bonding. But science fiction has long pondered silicon-based life, as silicon sits directly below carbon on the periodic table and shares some chemical properties. The detection of a complex, stable silicon-oxygen polymer in space reignites that speculative flame. Could this ghost emission be a signature not of life itself but of a probiotic chemistry favoring silicon? It suggests that in the harsh nurseries of space, the foundations for entirely different biochemistries might be quietly assembling themselves, writing their first molecular sentences in a language we are only beginning to decipher. That complex silicon polymer whispers of a new chemistry, but the 15th signal presents a mystery of abrupt, total silence. The vanishing carbon monoxide pulse began as a perfectly ordinary event. Carbon monoxide is one of the most abundant and reliable tracers in molecular clouds. Its specific radio emission allows astronomers to map the density and motion of the gas itself. In one particular cloud, a strong, localized carbon monoxide signal flared to life, a bright beacon in the radio data. There was nothing unusual about its intensity or its frequency. It looked exactly like a dense knot of gas, perhaps a tiny core beginning the long collapse into a star. Then, within a span of mere minutes, the signal vanished. It did not fade, weaken, or drift away. It simply ceased as if a switch had been flipped. This instantaneous cut-off is what makes the event so deeply perplexing. In the natural world, especially in the vast, slow-moving realm of interstellar clouds, nothing happens this fast. A pocket of excited carbon monoxide gas should cool and disperse over weeks, months, or even years, its signal dimming like an ember slowly losing heat. This was not an ember cooling, it was a light bulb being shattered. The sharp cutoff suggests the energy source that was exciting those carbon monoxide molecules was not just removed, it was annihilated. One compelling theory points to the decay of an exotic, short-lived particle. Imagine a massive, unstable particle, perhaps a product of a dark matter interaction or a rare cosmic ray collision, materializing briefly within that pocket of gas. As it blinks into existence, its decay products flood the local environment with energy, exciting the carbon monoxide and causing the flare. Then, within its brief lifespan, the particle completely decays away. The energy source winks out of existence entirely, and the excitation stops instantly. The carbon monoxide molecules, no longer being pumped with energy, immediately fall silent, returning to their cold, quiet state. The entire event is the particle's life and death captured in a radio flash and then a perfect void. An even more staggering possibility is that we witnessed a form of control. What if the excitation mechanism had an off switch? Natural processes do not have switches, they have gradients and equilibriums, but certain theoretical phenomena might. For instance, if the excitation were caused by a tightly focused beam of particles or radiation from a distant, unseen object, and that beam was suddenly blocked or redirected, the effect on the target gas would be immediate and total. The signal would vanish as if it had never been, leaving no trace because the cloud itself was never fundamentally altered, only briefly illuminated by a passing cosmic spotlight that then swung away. The vanishing carbon monoxide pulse leaves us with a haunting void in the data. It is a signal defined not by what was, but by what is no longer there, a reminder that some of the universe's most compelling messages are those that end without warning, leaving us to wonder what hand turned out the light. That abrupt silence left a void, but the next pair of signals creates a paradox of motion. Signals 16 and 17, the velocity vector decoupling, originate from the same dense knot within a cloud, a region you would expect to be a unified body of gas. Astronomers were mapping its internal motions by looking at the Doppler shifts of two common tracer molecules, sulfur monoxide and a cyanide compound. The Doppler shift is a fundamental tool. It tells us if an object is moving toward us or away by how its light is stretched or compressed. In a coherent pocket of gas, all the molecules should share a common drift, flowing together like a single stream. The data revealed something impossible. The sulfur monoxide signal showed a strong redshift, indicating it was streaming away from us at a significant velocity. But the cyanide emission from the exact same location showed a powerful blue shift, meaning it was hurtling toward us. These two molecular species, occupying the same space, were moving in violently opposite directions. This decoupling strikes at the heart of astrophysical fluid dynamics. In the standard model, a molecular cloud core is a single fluid. Collisions between molecules happen billions of times per second, forcing everything into a shared average motion. It is like stirring cream into coffee. The two liquids quickly become one homogeneous mixture, moving as a single entity. For sulfur monoxide and cyanide to maintain such radically different velocities while coexisting, they would need to be somehow insulated from each other, ignoring the relentless particle collisions that should blend their motions in an instant. So what force could possibly keep two gases in the same room from ever touching? One hypothesis suggests a magnetic separation on a colossal scale. Imagine this cloud knot is threaded by an immensely powerful, highly organized magnetic field. If the sulfur monoxide molecules carry a slight electrical charge or have a different magnetic susceptibility than the cyanide, the field could, in theory, act like a cosmic sorting mechanism. It could be channeling the two molecular populations along separate, invisible magnetic highways that crisscross the same volume, like trains on different tracks passing through the same station. They share the space but never interact because they are locked onto different guided paths. Another, more turbulent idea involves a phenomenon called differential drag. Perhaps the cyanide is not a free gas, but is largely absorbed or stuck to the surfaces of tiny, fast-moving dust grains. These grains, being solid, could be accelerated by radiation pressure or stellar winds to high speeds, dragging their cyanide passengers with them. The sulfur monoxide, meanwhile, remains in the gas phase, flowing in a different bulk motion. They would appear to be in the same place, but one is essentially hitchhiking on a fleet of microscopic rockets, while the other is the wind itself. This velocity decoupling is more than a curiosity, it is a direct challenge. It tells us that within these clouds, our assumption of a simple, well-mixed fluid is dangerously naive. The cosmos is capable of far more intricate and segregated motions, forcing us to consider that the birthplaces of stars may be woven with invisible threads and layered with currents we are only beginning to perceive. This violent separation of gases hints at hidden forces, but the 18th signal paints a different picture, one of a diffuse, pervasive warmth with no visible fire. In a specific, sprawling region of a molecular cloud, astronomers measured the ambient radio temperature. They expected to find the cold, smooth baseline of the cosmic microwave background, the faint afterglow of the Big Bang, perhaps with a slight thermal murmur from the cloud's own cool dust. Instead, they found a significant, unexplained boost. The entire background radio noise in this localized area was noticeably warmer, as if the cosmic room itself had been gently heated. This was the non-thermal background boost. The key word is non-thermal. If the cloud was simply being warmed by starlight, the emission would follow a predictable blackbody curve across all wavelengths. This boost was confined to the radio spectrum, and it was smooth, lacking the sharp spikes that would point to a single, powerful object like a hidden star or a pulsar. It was a diffuse glow without a discernible source, like walking into a room that feels warm but finding no radiator, fireplace, or light bulb to explain it. So what could be uniformly heating the radio sky across such a vast volume of space? One compelling theory imagines a cosmic population of countless faint emitters. Picture millions, perhaps billions, of unknown, low-power cosmic objects scattered throughout that region. Individually, each would be far too faint for our telescopes to pick out from the background. But collectively, like a vast swarm of radio fireflies, their combined emission could create a detectable, uniform boost in the ambient temperature. What these fireflies might be is a mystery in itself. They could be a previously unknown class of brown dwarfs, failed stars too small to ignite fusion but still crackling with magnetic activity. Or they could be exotic, cold objects like rogue planets with powerful magnetospheres, each contributing a whisper that adds up to a murmur. The other major hypothesis points to the architecture of the cloud's invisible skeleton. Magnetic fields are woven through all molecular clouds. Normally, they are tangled and chaotic. But if, within this specific region, the magnetic field were unusually well organized and powerful on a large scale, it could act as a giant particle accelerator. Electrons spiraling along these coherent field lines would produce synchrotron radiation, a broad, smooth radio glow. The scale and uniformity of the field would determine the smoothness of the boost, creating a gentle, pervasive warmth without any single bright knot. This would be like the cloud itself becoming a faint, galaxy-sized fluorescent tube, energized by an invisible current. The non-thermal background boost challenges our perception of emptiness. It suggests that what we often dismiss as mere background static may, in certain places, be the integrated signal of a hidden population or the signature of a vast, ordered force, turning the space between the stars into a canvas of subtle, collective light. That pervasive, invisible warmth is a signature of collective energy, but the 19th signal is a beam of disciplined light. From a specific filament within a cloud, we detect an emission with an astonishingly high degree of linear polarization. This means the radio waves are not just arriving randomly, they are vibrating in a single, locked plane, like sunlight reflecting off the surface of a still lake. Such polarization is often the work of powerful, organized magnetic fields threading through cosmic plasma, which can align the waves as they travel. The true anomaly, however, is not the polarization itself, but its behavior. This perfectly aligned signal does not remain constant. It oscillates rhythmically, its angle of polarization shifting back and forth with a steady, predictable cadence. It is as if the beam itself is slowly rotating, or the lens through which we view it is methodically turning. This rhythmic oscillation is the fingerprint that defies simple plasma physics. A chaotic, turbulent magnetic field in a cloud filament might produce strong polarization, but it would be a static or randomly flickering alignment. To generate a clean, periodic swing requires a driver with remarkable regularity, a cosmic metronome governing the magnetic environment itself. One compelling natural explanation points to a hidden, spinning anchor. Imagine a dense, magnetized object buried within that filament, perhaps a young, rapidly rotating neutron star or an unusually magnetic brown dwarf. As this object spins, its powerful, structured magnetic field would sweep through the surrounding gas like a lighthouse beam. Any radio emission generated within that influenced zone would inherit the field's orderly polarization, and as the object rotates, the angle of that polarization would appear to oscillate from our distant vantage point. The entire filament would act like a fluorescent tube, glowing with polarized light that pulses in time with the hidden spinner's rotation. Yet, the precision of the oscillation invites a more speculative line of thought. In our own technology, we manipulate polarization for a very specific purpose: directional transmission. A deliberately polarized signal maintains its strength and integrity over vast distances better than an unpolarized one, and controlling that polarization can be a way to aim information. Could this rhythmic swing be a signature of such manipulation on a cosmic scale? It is not evidence of a message, but perhaps evidence of a method. If something within that cloud were using the natural magnetic fields as a lens or an amplifier to send a focused beam across the galaxy, the act of steering or modulating that beam could imprint this exact kind of rhythmic polarization shift onto the signal. We are left observing a beam of extraordinarily disciplined light, its slow, steady swing pointing less to chaos and more to control, whether from a spinning celestial clockwork or something else entirely, using the fabric of the cloud itself to craft a beacon. This disciplined beam of polarized light reveals a hidden order, but the 20th signal points to a profound anomaly in the cloud's most basic ingredient. In one specific, dense core, astronomers measured the ratio of deuterium to normal hydrogen. Deuterium, often called heavy hydrogen, is a stable isotope with an extra neutron in its nucleus. It was forged in the fiery first minutes of the Big Bang, and its universal abundance serves as a cosmic benchmark, a fixed percentage of all hydrogen. Within this cloud core, that benchmark was shattered. The deuterium signal was not just slightly elevated, it was massively overabundant, a localized spike in heavy hydrogen that defies all standard models. This is not a small statistical fluctuation, it is a glaring chemical outlier. So where did all this extra deuterium come from? The two usual cosmic sources fail to explain it. Big Bang nucleosynthesis set the initial uniform ratio for the entire universe. Later processes like cosmic ray spallation, where high-energy particles smash into heavier atoms and chip off deuterium, can create small, local enhancements. But the scale of this excess is far too large for spallation alone. It would require an unimaginable and sustained bombardment of cosmic rays focused on this one spot, which we do not see. The cloud core appears to be holding a private stockpile of primordial material, a cache of heavy hydrogen that should have been blended away eons ago. This forces a radical question. Could this deuterium have been delivered from somewhere else entirely? One compelling hypothesis points to an ancient, exotic visitor. Imagine a rogue object from the earliest days of the galaxy, something that formed in an environment with a fundamentally different deuterium ratio. A primordial asteroid or a comet from the outer reaches of a long-dead planetary system, rich in deuterium locked in its water ice, could have plunged into this cloud core. As it disintegrates, it would seed the local gas with its unique isotopic signature, like a drop of dye spreading in a glass of water. But to create the observed excess, the object would need to be staggeringly massive, perhaps a dwarf planet or even a minor planet from a system that formed before the galaxy's chemistry was fully mixed. An even more profound possibility connects this signal to the life cycle of stars themselves. Some theoretical models suggest that certain rare types of supernova, or the violent mergers of neutron stars, could produce significant amounts of deuterium in their explosive outflows. If such an event occurred nearby in the relatively recent cosmic past, its debris, enriched with freshly minted heavy hydrogen, could have snowplowed into this molecular cloud, contaminating this one pocket with its unique fingerprint. The deuterium excess is therefore a forensic clue written in the simplest of atoms. It tells us that this cloud, or at least this part of it, is not a pristine sample of the universe. It is a repository for something ancient or a recipient of a violent donation, its elemental purity compromised by an event that left behind a cryptic signature in the very heart of its hydrogen. That profound anomaly in the cloud's hydrogen points to a history of contamination or violent donation. But the 21st signal is a mystery of subtraction, not addition. It is known as the missing photon resonance. Astronomers were mapping a relatively transparent region of a molecular cloud, a section thin and diffuse enough that background starlight from distant galaxies should shine straight through. At one specific radio frequency, however, the light did not get through. The data revealed a deep, sharp absorption line, a narrow band where the expected background photons simply vanished. This was not a gradual dimming, it was a precise surgical removal of light at one exact color. The cloud, which should have been clear at that frequency, contained something acting as a nearly perfect filter, catching those specific photons with astonishing efficiency. Think of it like a pane of perfectly clear glass that, for one specific shade of red, becomes completely opaque, absorbing every single photon of that color while letting all other light pass unaltered. The natural question is, what inside a sparse cloud could be such a voracious and selective eater of light? To absorb photons this cleanly at a single frequency requires a substance with a correspondingly sharp and powerful resonant transition. In simple terms, the atoms or molecules doing the absorbing must have an electron or a molecular bond that vibrates at exactly that frequency, and it must be present in enormous quantities to soak up all the light. Common interstellar molecules like carbon monoxide or water have such transitions, but they would also leave a host of other spectral fingerprints that are completely absent here. This absorber is a ghost, revealing itself only through this one act of theft. The leading hypothesis is as compelling as it is elusive. We may be detecting the signature of a vast reservoir of an exotic particle or an ultra-complex molecule that is otherwise incredibly difficult to see. This substance would have to interact with light only at this one specific frequency, remaining dark and inert across the rest of the electromagnetic spectrum. It could be a specific isomer of a large organic molecule, a rare configuration that exists in staggering abundance only in this cloud. Or, more speculatively, it could be a condensate of a theoretical particle like actions, which are a prime candidate for dark matter. Under certain conditions, such a condensate could, in theory, absorb photons of a very specific energy as the particles make a collective quantum jump. The sheer depth of the absorption line suggests this absorber isn't a trace contaminant. It is a major constituent of the cloud in that region, a hidden component of the interstellar medium we have been blind to. The missing photon resonance is therefore a negative image, a silhouette of something vast and unknown. We cannot see the thing itself, but we can see the perfect shadow it casts on the light of the universe. A shadow that tells us a significant portion of reality in that cloud is made of something our science has not yet named. The shadow of an unseen absorber is a profound mystery of absence, but the 20-second signal is one of cosmic choreography. From a molecular cloud drifting along the edge of one of our galaxy's great spiral arms, we detect a transmission whose very nature seems to dance with the galaxy's grand architecture. Its intensity rises and falls, its bandwidth narrows and widens, in a pattern that maps perfectly onto the cloud's position relative to the dense star-forming lanes of the spiral arm itself. It is as if the entire local galactic environment is acting as a modulator, a vast celestial hand turning the volume and clarity of this signal up and down. This correlation is too precise to be coincidence, yet the scale of the interaction is baffling. Spiral arms are immense gravitational density waves sweeping through the galactic disk, compressing gas and triggering star formation on scales of thousands of light years. How could such a slow, grand structure exert such a finely tuned influence on a radio signal from a single, relatively tiny cloud? The physics points to an indirect but powerful chain of causation. As the cloud orbits the galaxy and enters the enhanced density of a spiral arm, the ambient environment changes dramatically. The flux of cosmic rays, those high-energy particles from supernova and other violent events, increases significantly within the arm. This particle rain could be the primary modulator, bombarding the cloud and exciting specific molecules or plasma within it, thereby boosting the signal's intensity. Furthermore, the interstellar magnetic field is thought to be stronger and more ordered within spiral arms. This amplified and organized field could then focus and polarize any emission from the cloud, effectively narrowing its bandwidth and cleaning up the signal, making it appear sharper and more structured as the cloud moves through the arm's magnetic lane. Then, as the cloud drifts back out into the quieter inter-arm region, the cosmic ray flux drops, the magnetic field becomes more chaotic, and the signal fades and broadens back into the noise. The process is a form of celestial amplification, where the galaxy's large-scale structure provides the power and the lens. Yet, the sensitivity of this modulation is what remains truly startling. It suggests the cloud contains a component exquisitely tuned to these galactic conditions, perhaps a specific molecular transition or a plasma state that acts like a perfect sensor, its radio output serving as a direct readout of the local interstellar weather. The spiral arm modulator transforms the cloud from a passive object into an active gauge, its signal etching a real-time record of its passage through the grandest structures in our Milky Way, whispering secrets about the forces that shape entire galaxies. This galactic modulation reveals a cloud exquisitely tuned to its environment, but the 23rd signal exposes a tiny, stubborn flaw in that harmony. It involves a family of molecules known as polycyclic aromatic hydrocarbons, or PAH. These are flat, stable molecules of carbon and hydrogen, like microscopic hexagons of soot, and they are incredibly common throughout interstellar space. When excited by starlight, they emit a distinctive set of infrared bands, a chemical fingerprint astronomers use to trace the presence of organic material. In one particular cloud, however, this fingerprint is slightly smudged. The entire pH emission band is minutely, but definitively, redshifted compared to every other molecular line detected from the same region. All the other gases, the carbon monoxide, the ammonia, the cyanides, they all sing in unison, indicating a shared bulk motion for the cloud. The PAH alone are singing a fraction of a note flat. This is the pH glitch, a subtle but profound velocity anomaly. It means this population of carbon rings is drifting ever so slightly away from us compared to the rest of the cloud material surrounding it. The discrepancy is small, perhaps only a few kilometers per second, but in the precise world of spectroscopy, it is a glaring inconsistency. It cannot be explained by the cloud's overall rotation or its motion through the galaxy, as those forces would affect everything equally. This glitch is local, a tiny pocket of rebellion within the cloud's dynamics. So what could cause one specific type of molecule to lag behind or drift apart from the cosmic flow? The leading explanation delves into the delicate interplay between light and motion. PAHs are unique because they are not just floating in the gas, they are also incredibly sensitive to radiation pressure. When a photon of starlight strikes these flat molecules, it can give them a gentle push. The other, simpler molecules are largely transparent to this specific light, or they are shielded deep within denser clumps of gas. The PAH, however, are like microscopic solar sails, constantly feeling the faint pressure of starlight. If there is a slight asymmetry in the radiation field bathing this part of the cloud, perhaps from a nearby star just off to one side, it could be preferentially pushing the PAHs in a different direction, creating that tiny redshift relative to their protected neighbors. Another possibility involves the very beginning of a gravitational collapse. Imagine this region is a candidate for a future star, a core starting to slowly contract under its own weight. As it collapses, everything should fall inward together, but PAH, due to their size and structure, might interact differently with magnetic fields or experience a form of aerodynamic drag against the background gas. They could be decelerated just a fraction more, like leaves caught in an eddy while the water flows smoothly onward. This glitch, then, could be the earliest detectable signature of a star's birth, a minuscule tear in the fabric of the cloud's unity that heralds a much greater separation to come. The pH glitch is a whisper of differential motion, a reminder that even in the apparent chaos of a turbulent cloud, there are layers of order and separation, where different constituents can tell subtly different stories about the forces acting upon them, stories written in the precise shift of a single spectral line. That subtle drift of molecules reveals a hidden stratification. but the 24th signal confronts us with a blast of raw energy held in an impossible grip. Within a dark nebula, astronomers have pinpointed a source of intense broadband radio noise, a chaotic roar spanning a wide range of frequencies. Such noise is common in the universe, often emanating from vast, turbulent regions like supernova remnants or the agitated gas around black holes. What makes this source, Signal 24, an absolute anomaly is its shape. This furious blast of radiostatic is not diffused across a sprawling area. It is perfectly confined, squeezed into a remarkably small, spherical volume deep inside the calm molecular cloud. It is as if a raging, sonic wildfire has been trapped inside a perfectly clear glass marble. The natural tendency of such energetic emission is to scatter, to dissipate its energy outward in all directions, smearing itself across light years. Something here is holding it in, maintaining a coherence that defies the second law of thermodynamics. The very existence of this tight sphere of noise implies an internal confining force of staggering power, a container strong enough to withstand the violent pressure of the radio blast trying to escape. So what kind of cosmic bottle could hold this lightning? The immediate suspect is gravity. For gravity to confine something this energetic, the mass required within that tiny volume would be immense. We could be looking at the signature of a very dense, very dark object, like a black hole of intermediate mass, actively feeding on the surrounding cloud material. As gas spirals in at near light speed, it becomes superheated and emits a torrent of radio waves. The black hole's immense gravitational pull would then act as a natural event horizon for the radiation, containing the outburst within a defined volume around it. The spherical shape fits this model perfectly, yet there is no accompanying X-ray signature we would expect from such violent accretion, leaving a puzzling gap in the data. The other prime candidate is magnetic pressure. Imagine a knot within the cloud where magnetic field lines have become incredibly tangled and amplified, twisted into a self-contained spherical cage. Within this magnetic prison, charged particles are accelerated to tremendous speeds, crashing into one another and generating the broadband radio roar. The magnetic pressure from the walls of this cage prevents the particles and their emission from escaping, acting like the walls of a fusion reactor containing a plasma. This would be a natural magnetic containment vessel, a stellar phenomenon on a scale and stability we have never before witnessed. The mystery deepens because both explanations, the gravitational prison or the magnetic cage, point to an object or a condition of extreme and unusual power residing quietly in a place of stellar birth. This confined blast of noise is not a signal in the traditional sense. It is the desperate sound of something trapped, a cosmic tantrum contained within an invisible, unbreakable sphere, challenging our understanding of how energy behaves in the silent depths of space. A perfect sphere of contained chaos gives way to the final signal, the one that forces every other mystery into a new and chilling light. Signal 25 is the alien frequency spike. From the heart of a dense molecular cloud, astronomers recorded a radio emission so specific it seemed to defy the very concept of coincidence. It was a narrow-band spike, a single, pure note on the cosmic radio dial, but not just any frequency. This spike appeared precisely within the range astronomers call the water hole, a quiet band of the radio spectrum bookended by the natural emission lines of hydrogen and hydroxyl, the components of water. This region is not chosen arbitrarily. For decades, scientists engaged in the search for extraterrestrial intelligence have proposed it as an ideal channel for interstellar communication, a naturally quiet spot in the galactic noise where a deliberate signal would stand out with crystalline clarity. A universal oasis where any technological civilization might think to listen or to call out. And there it was, the signal's technical characteristics only deepen its profound strangeness. Its bandwidth was incredibly narrow, far narrower than any known natural astrophysical process can produce. A pulsar's beam, a maser's glow, even the chirp of a collapsing star, all produce emission that is smeared across a range of frequencies. This was a laser line, a pinprick of specificity. Furthermore, its power was significant, requiring a substantial release of energy focused with impossible precision. To generate such a spike naturally would demand a mechanism that not only produces vast energy but then funnels it through a filter of unimaginable fineness, a cosmic accident of staggering improbability. The location within the molecular cloud adds another layer of profound ambiguity. These clouds are the murkiest places in the interstellar medium, filled with dust that scatters and absorbs radio waves. For a signal this clean and powerful to emerge from such an environment, it either had to be generated deep within the cloud itself by a source we cannot comprehend, or it must be so immensely powerful that it punches through the obscuring dust without distortion, its original clarity preserved. Both possibilities are extraordinary. The first compels us to ask what natural engine, hidden in a stellar nursery, could possibly be tuned to the waterhole with such fidelity. The second asks what could be so powerful and so deliberate. This is the weight of Signal 25. It does not prove anything, but it compels a question we have asked for centuries in a new and urgent way. When every other explanation strains credulity, we are left staring at a frequency chosen by our own science as a logical place for a greeting, hearing a tone of perfect clarity, and wondering if, within the swirling dust where stars and planets are born, something else was already waiting, speaking on a channel we had only just begun to monitor. 25 signals from the darkness, each a unique puzzle. Yet when we step back from the individual mysteries, something even more profound comes into view. These are not random, disconnected glitches in the data. They are part of a pattern, a chorus of contradictions singing the same unsettling tune about our understanding of the cosmos. Look at the common threads weaving through them. First, nearly all involve non-thermal emissions. The energy we detect does not come from simple heat. It is structured, focused, and often too clean for the chaotic environments we observe. From the WOW cloud's perfect spike to the rhythmic polarization swing, these signals suggest processes that channel energy with a precision that mimics engineering. Second, we see a recurring defiance of equilibrium. The methanol and formaldehyde twins show a selective chemical excitation, while the silicate signature reveals inexplicably warm dust in a deep freeze. These are systems out of balance, pockets of the universe where the natural drive toward disorder is being thwarted by an unseen, organizing force. Third, there is the theme of impossible stability and periodicity. The carbon ring echo ticks with atomic clock precision for hours. The ammonia harmonics ring with a purity that demands a perfect resonator. In the turbulent hearts of stellar nurseries, such steadfast rhythms should be the first thing destroyed, yet they persist. Finally, the discrepancies in motion and composition scream of hidden layers. The velocity vector decoupling shows gases moving in opposite directions in the same space. The deuterium excess reveals a private stockpile of primordial material. The pH glitch shows molecules drifting on their own. These are not minor measurement errors, they are fundamental violations of how we believe matter and motion behave in these clouds. The sheer number of these anomalies and the consistency of their themes points to a single, inescapable conclusion. We are not looking at 25 isolated mistakes or rare flukes. We are witnessing the symptoms of a profound, systemic gap in our knowledge. Our standard models of interstellar molecular clouds, the very cradles of stars and planets, are incomplete. There is physics at work within these dark nebulae that we have not yet discovered, forces that organize matter, focus energy, and defy equilibrium on scales we are only beginning to perceive. The universe is not just stranger than we imagine. It is actively demonstrating that strangeness, broadcasting our ignorance back to us on 25 different frequencies. Faced with this chorus of contradictions, scientists have been forced to propose explanations that stretch the boundaries of known physics. the theories fall into three bold and sometimes unsettling categories. The first theory seeks the answer in the universe's most abundant unseen substance. Dark matter is believed to weave through every galaxy and cloud, a ghostly scaffold holding the cosmos together. Some researchers propose that certain signals, like the unexplained background boost or the sudden chirp of helium, could be the death throes of exotic dark matter particles. Imagine these particles, after drifting silently for eons, finally colliding and annihilating within the dense heart of a molecular cloud. That annihilation would not produce light, but it could release a spray of secondary particles, electrons and positrons with very specific energies. This tailored particle rain could then selectively excite hydrogen molecules, warm silicate dust, or trigger brief, intense radio chirps, creating the precise and localized anomalies we detect. In this view, the cloud is not the source but the canvas, and dark matter is the invisible brush painting strange signatures across it. The second category of theory looks not to invisible particles but to unimaginable chemistry. Our understanding of interstellar molecules is based on conditions we can replicate or model, but these clouds are ancient, complex, and vast. What if, within their ultra-cold, high-radiation environments, matter assembles in ways we have never dreamed? The polysiloxane ghost and the missing photon resonance could be hints of this. Scientists speculate about mega-molecules, vast carbon-silicon polymers or crystalline structures light-years across that form under these exotic conditions. These cosmic-scale molecules would have vibrational and rotational transitions unlike anything in our laboratories, absorbing and emitting energy at specific, sharp frequencies. They could act as natural resonators, filters, or amplifiers, creating the harmonic tones, the selective absorption lines, and the structured emissions that so baffle us. This is not the chemistry of life, but a chemistry of the void, where elements combine over millions of years to form architectures of staggering complexity and scale. Then there is the third category, the one that forces a profound shift in perspective. The extraterrestrial intelligence hypothesis does not claim to answer every signal, but it asks a pointed question about the most anomalous ones, particularly those displaying engineered-like precision. Could the perfect 4.3-hour pulse of the carbon ring echo be a carrier wave? Might the narrow-band spike in the water hole be exactly what it appears to be, a deliberate beacon? This theory does not necessarily envision little green men at controls. It considers concepts like astroengineering, where a civilization immensely more advanced than our own might build structures on a stellar scale. The waste heat or communication leakage from such massive infrastructure, perhaps a Dyson swarm under construction or a galactic network node, could manifest as non-thermal emissions, structured pulses, or polarized beams emerging from the raw material of a molecular cloud. The cloud, in this scenario, provides both the raw materials and the camouflage. These three theoretical paths, dark matter, exotic chemistry, and ETI, are not mutually exclusive. In fact, the true answer may be a blend, where newly discovered natural physics creates phenomena so orderly they mimic design. Yet their simultaneous consideration reveals the extraordinary position we are in. To explain the whispers from these stellar nurseries, we must seriously contemplate the decay of unseen particles, the formation of impossible molecules, or the presence of intelligence beyond our own. Each possibility rewrites our story of the universe, and all three are now on the table, demanded by the data itself. These 25 signals are not a conclusion but a new beginning. They force a humbling admission: the fundamental astrophysical principles we use to map star formation and decode molecular chemistry are incomplete. Our textbooks describe these clouds as simple, turbulent cauldrons where gravity eventually wins. But the data now paints a portrait of profound complexity, where magnetic fields might sculpt matter into impossible shapes, where dark matter may whisper through chemical reactions, and where the very dust itself can resonate like a cosmic instrument. The cradles of stars are not passive nurseries, they are dynamic, layered, and filled with processes we are only starting to perceive. This is the true weight of the mystery. It is not about finding one answer, but about rewriting an entire chapter of cosmic science. To stand beneath a starry sky is to feel a familiar awe, but now that awe has a new dimension. We are not just looking at the silent, beautiful results of cosmic processes. We are actively listening to their raw, chaotic, and inexplicable middle acts. The universe is speaking to us in a language of anomalies, of glitches and perfect tones, of shadows and sudden silences. Each unexplained signal is a direct invitation to look deeper, to think more boldly, and to embrace the thrilling uncertainty that defines true exploration. The greatest discovery is not a single answer, but the realization of how much more there is to hear, reminding us that the cosmos is far stranger and far more wonderful than we ever dared to believe. Two signals stand out not for their complexity but for their chilling clarity. The first clue, the Wow cloud anomaly, was a single, perfect spike, a radio note of such unwavering precision it seemed engineered. And the final, haunting echo, the alien frequency spike, spoke on the very frequency we had designated as a logical place for a cosmic hello. These are the bookends of our mystery, one a whisper of impossible focus, the other a shout in a silent sanctuary. Between them lie 23 other enigmas, each a piece of a puzzle we are only beginning to assemble. So now the question turns to you. Which of these 25 unexplained signals captures your imagination the most? Is it the rhythmic, ticking patience of the carbon ring echo, or the violent, contained chaos of the spherical radio blast? Perhaps it is the ghostly separation of gases moving in opposite directions, or the warm dust in a cosmic deep freeze. Tell us in the comments below. Your perspective is a vital part of this ongoing search because unraveling these mysteries requires more than telescopes and equations. It requires our collective curiosity. If you want to join the hunt for the next great cosmic secret, make sure to subscribe. Our journey into the unknown is just beginning. As we leave you tonight, picture the vast, dark silhouette of an interstellar molecular cloud, a stellar nursery against the starry veil. And if you listen closely, beneath the silence, you might just hear it, the faint, unresolved crackle of cosmic static, a reminder that the universe is still speaking, waiting for us to understand.